Let's go ahead and take a look at a demo of this load balancer tool. So I've got a small server set up here. Let me show you to you. MC admin info. OS1 is my service, and I'm running a very simple server. It's got one server in the cluster. It's got 4 drives. It's only about 20 gigs of space or so. But basically what I'm doing here is I'm giving myself a very simple setup. Now this setup right now, if I go to the console, is actually going to be allowing all of its ingress through direct access, right? So this is kind of how you might come across this to begin with. So I've got a service node port for both my console UI and my object API. So this gives me this nice basic layout for all of my tooling. So what I want to do now is I want to go ahead and add that load balancer. So if I click on load balancer right here, I can click enable load balancer, and that's going to fire up a load balancer instance. This is going to run as a sidecar to my existing MinIO service. And if I take a look at the Kubernetes console, I'd be able to see that I've got this additional pod up and running. But at this point, there's no rules written for this. And because there's no rules written for this, I want to make sure that I have some kind of rule available. So I'm going to go ahead and do an add rule. Now this rule that I'm going to add, I'm going to call it LB load balancer, very slow. What I'm going to do here is I'm going to actually set up a load balancer command that is going to be extraordinarily slow. It's going to be designed to slow down upload speeds. And the reason why I'm doing this is just for the demo. This is probably not something you would do in production. But I need to select a bucket or I can't make this change. So I'm going to go ahead and select my LB bucket that I already have out there. And I'm going to make this an access rule. I'm going to throttle my bandwidth and I'm going to make this very, very slow. I'm going to do 256 bytes per second. Very, 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 very slow indeed. Okay. And what this is going to do is it's going to ensure that you can actually see a smaller object being uploaded quickly. So I'm going to go ahead and save this rule. And now that I've saved this rule, what we're going to do is we're going to come back over and we're going to go ahead and copy an object from my local system up to this bucket, MC CP. It's going to be sample.txt, and I'm going to send it up to OS1 LB bucket. Easy enough. However, it runs very, very quickly. Obviously, 10 kbps per second is not going to work. This means that I'm actually not slowing down my upload. So what happened? I set up my load balancer, I set up a rule, but you have to make sure that you're routing all of your traffic through the load balancer. So this is a common mistake, which I'm showing off. And what I'm going to do is I'm going to go ahead and go back in here to my inbound traffic, and I'm going to redirect all my traffic through my load balancer. So right now it's direct access. I'm going to turn that off. What I am going to do is I'm going to turn it on for the load balancer, and I'm going to use the same service node port so that to the end user, it's transparent. I don't have to update any of my MC aliases. I don't have to update any of my other connections. 30011 is the one that I was using for the console UI, and I'm going to go ahead and save that. Okay. Now my inbound traffic has been updated appropriately. Okay, and now that we've actually applied the load balancer, we're routing our traffic through the load balancer. I'm going to do an MC CP. I'm going to copy that sample text back up to OS1, LB bucket again, and let's take a look. Notice now it is moving much more slowly. I've routed the traffic through my load balancer. I've got all of my data going through the load balancer now. And what this means is at the end, you're going to see my average upload speed is going to be right around 256. And there it is. About 20 seconds to upload this 4 kilobyte file because I drastically limited the speed. Again, you're probably not going to do that in production. But there is another way that you can actually put limits on your data, not just throttling your bandwidth. One of the more interesting things that you can do is you can actually set up rules that limit the number of API requests per second. And one of the API requests per second that you might want to limit if you are exposing your system as SFTP or FTP is you might want to actually go in and say, I want to make sure that anybody accessing my bucket over FTP can only send a certain number of requests. That way they can't flood your server with a bunch of FTP requests. So I'm going to go ahead and create a new rule here called LB FTP protection. And I'm going to put this also on the LB bucket. it's going to be an access rule, and the request limit is what I'm looking at here. Now, when I click on new request limit, I'm presented with a rate and a burst. These are both in requests per second. The burst is if I'm going to have maybe a moment where I have a lot of extra traffic and I don't necessarily want to put a stop to it, but the burst is not going to be the sustained rate. The sustained rate is the rate that we're going to put in. So I'm going to put in 10 per second for my rate, 100 per second for my burst. And then what I'm going to do is I'm going to select my API. Now, all of these API notations are actually the same thing you would see in a policy setup. It's going to say, what can I do in the API? And there's lots of different ones in here. For instance, maybe I want to copy an object. Maybe I want to delete buckets or delete objects. So all of these things are tasks that you might perform, but you want to make sure that nobody can flood your server with a bunch of these calls. Way down here at the bottom, here is my SFTP. I'm going to put this limit and say SFTP put. I can only put 10 per second. That means I cannot flood my SFTP server with too many requests. And if I save that, that is going to be yet another rule. They're both on the same bucket. I could actually put both of them on the same bucket if I wanted to. It's sometimes handy to have them separate, just depending on how you want to manage rules. But this is going to allow me to have that request limit. I don't have a system to send that many requests over FTP, so I'm not going to show you how that works. But that allows you to set up API key-based rules to limit the number of requests per second, as well as being able to limit the bandwidth being used. The last thing that you can set up with this, either on a per bucket basis or globally, is anonymous access, which is going to allow you to read objects from your system without having a login. Sometimes that's useful, sometimes it's not. But again, something that you can actually do through the load balancer rules. And that's everything that I want to show you for this demo. Hope you've enjoyed. If you'd like to reach out with us, you can connect with us on Slack at slack.min.io, or you can just leave a comment here on the video. Thanks, and we'll see you for the next one.